thank you all for coming out to listen to me drone on for a few minutes. And thanks, of course, to the organizers for allowing me to be here to speak with you. I've written a talk that's somewhat shorter than the amount of time we have, simply because as a professor, I like to have some feedback with the people who are listening to me. So hopefully we'll have some time for Q&A at the end. So hold on to your questions. So when I was invited to speak here, I was given the title of this breakout session, Understanding the Scientific Revolution. And I thought that was quite helpful because I've been trying to understand the scientific revolution for about 40 years. And I realize I'm not there yet, but at least for the next 40 minutes, I'll share with you some of the things that I think about the scientific revolution. I'm also going to talk about where the scientific revolution goes, what happens to the ideas that came out at that point. So we'll look at some more modern developments and even some medieval developments that lead up to it. Well, I think I can begin with a very simple statement that there's no question that we live today in a world of science and technology. We can barely live our lives for more than a few seconds without getting out cell phones and texting people or turning on the microwave or the air conditioning or the central heating or whatever. And so science and technology is around us everywhere. Even at a deeper level, the ways we conceive of and think about the world and ourselves are colored and molded by the outlooks, the metaphors, and the insights that come to us from science and technology. So the question is, how did this world come to be? And what does this state of affairs, this new kind of world, mean for philosophies, for religions that were expressed in terms borrowed from a different age? Well, many of the fundamental conceptions about the universe we inhabit, about the ways in which it functions, the ways in which we relate to it, date from what is sometimes considered the most transformational period in the history of science, the scientific revolution. Well, before I go on, I want to make sure we're actually all on the same page about what the scientific revolution is and when it is. And I know this only because when I'm teaching 21 and 22-year-old students and I talk about the scientific revolution or the early modern period, they think I'm talking about the 1980s. Which, if true, means that I was born in the Middle Ages, which the more I think about it and the longer I live, the more attractive that actually seems. Nevertheless, when historians of science speak of the scientific revolution, we refer predominantly to the 16th and 17th centuries. Many of the most famous historical scientists lived in this period. It's easy to rattle off a list of them: Copernicus, Kepler, Galileo, Descartes, Harvey, Boyle, Newton, Leibniz, and so on. And the period's major discoveries and reconceptualizations are also too numerous to list. When an Earth-centered cosmos replaced a sun-centered one, when the regular motions of the heavenly bodies were explained, when the foundations of classical physics were established, the circulation of the blood demonstrated, the first scientific societies founded, the new world and new regions of the old world explored, the cosmos mathematized, quantified, and cataloged like never before. It was also when mechanical, technological metaphors began replacing more organic ones, and when human beings began reconceptualizing and reimagining their place in relationship to the universe. Now, while all these developments of the scientific revolution are largely agreed upon, there are some other less reliable claims, particularly those relating to my theme today, that is the dynamic between science and religion, that have also been made. Chief among these is the assertion that it was during the scientific revolution that the progress of scientific knowledge brought faith and reason into conflict, and that such conflict has continued and in fact intensified down to the present day as science progressively displaces or replaces religion. So the scientific revolution is seen by some as a turning point for both science and religion, a positive one for science, a negative one for religion. Yet, on a closer examination, not even that close an examination to be perfectly honest, this claim is based on a number of falsehoods. and actually draws its origins not from the 16th or the 17th century, but from retrospective assertions that were motivated by social, political, and often very personal aims dating from at least 2 centuries later. I'll get to what those are in a few moments. So let's look then at these falsehoods and their origins. I think there are 3 interrelated historical errors here. Number 1, that the crafters of the scientific revolution were themselves non-religious or even irreligious. 2, that religion and faith played either a negative adversarial role or no meaningful role at all in the scientific revolution and by extension ever after. Number 3, that the relationship between science and religion is a zero-sum game. That is, as one advances, the other must necessarily retreat. So there's a great deal to say about each of these. But let's start with the first, about the crafters of the scientific revolution. To professional historians of science today, the claim that the crafters of the scientific revolution were irreligious or non-religious is, well, so absurd as to lie below our notice. That has not, however, stopped a herd of popular writers and a fair number of scientists who imagine that they can speak authoritatively on historical matters. It's a fault I find particularly common among physicists and evolutionary biologists. Nevertheless, they've kept on repeating it. Well, the evidence to the contrary is so overwhelming, I could just give a few examples, and we could go on all day with this. Let's take Robert Boyle. You've probably heard of Boyle's law if you've taken any chemistry at all. He was a champion of chemistry, discoverer of a fundamental gas law. He was called in his eulogy a lay bishop, and his many books divide evenly between scientific and theological topics. His most popular work, in fact, was a book of devotion. Isaac Newton devoted at least as much time to theology, Christology, and biblical studies as he did to mathematics or physics. And the general scholium to his famous Principia Mathematica, the book that sets the foundations for celestial mechanics based on his notion of a universal gravitation, contains substantial theological speculations. And there he firmly states, and I quote, "To discourse of God from the appearances of things does certainly belong to natural philosophy." And it's trivially easy to cite a long list of scientific work and achievements carried out by those in holy orders. In the middle of the 17th century, concepts of atomism were revived, improved, and extended by the French priest Pierre Gassendi. The foundational principles of geology and stratigraphy were enunciated, and the nature of fossils as the relics of living creatures demonstrated by Niels Stenson, or Steno, who converted from Lutheranism to Catholicism, then became a priest, a bishop, and is now a beatus. The list of 17th century Jesuits reads like a roster of significant scientific discoverers. Giovanni Battista Riccioli measured quite accurately the constant of gravitational acceleration by dropping weights from the towers of Bologna. My favorite part about this is that he needed to measure the amount of time very, very carefully. And so he tried to make a pendulum that would beat exactly once per second. Well, can you tell? The only timekeeper we have is the sun. So he would measure when the sun crossed the meridian, that would be exactly noon, start the pendulum, and then he made the Jesuit novices sit there and count until the sun reached the meridian again 24 hours later. And mind you, it took a lot of tweaking to get it to be exactly 1 second per beat. The novices finally rebelled, and instead the way he timed things was he had the novices stand at the bottom of the tower, and they would repeat a prayer very, very quickly, which they knew very well, and then notice at what syllable the ball hit the ground. All right. Just like graduate students. Athanasius Kircher descended into the crater of an erupting Mount Vesuvius to make observations on volcanism. Now, my image of this in my mind, which I know is not true, is I see him in a cassock and beretta on the end of ropes being lowered down into the crater. I'm sure it didn't happen that way, but that's my imagination. Francesco Maria Grimaldi first observed, described, and studied the diffraction of light, a phenomenon satisfactorily explained only in the 20th century. And the topics of magnetism, optics, and seismology were, at various times, virtually Jesuit monopolies. It's recently been discovered that the Jesuits were the very first to teach Galileo's new science of motion in their Roman college. And having mentioned Galileo, who is frequently, erroneously, naively, cited as the prime example of a conflict between science and religion, it's necessary to point out that he remained Catholic to the end of his life. In fact, at one point, he received the tonsure to get a church benefice. And his letter to Queen Duchess Christina, which was intended to answer her questions about the theological consequences of heliocentrism and a moving earth, is a masterpiece of, not necessarily scientific, but rather theological reasoning based firmly in the exegetical tradition of St. Augustine, which he clearly knew very well. In fact, by the way, one of his early missteps was his attempt to reinterpret Scripture to support one of his scientific observations, one of his scientific theories, one which later turned out to be wrong. That was an extremely unwise undertaking in the days when Protestants were throwing out centuries of learned biblical commentary and exegesis in favor of their own ideas. Misstep, Mr. Galileo. But the important thing really is how seriously he took theology and biblical interpretation. I can say more about Galileo in the questions section if you like, but I'll now just point out that his supporters and detractors were evenly distributed among ecclesiastics and laymen, and both criticism and support of his ideas were based on both theological and scientific ideas. Pope Urban VIII was his friend, was delighted by his book, The Assayer, well, at least until he believed Galileo had deceived him and embarrassed him publicly. The Jesuits gave him a celebratory feast to mark his telescopic discoveries, and Galileo himself liked to quote Cardinal Cesare Baronio, who quipped, quote, "The intention of the Holy Spirit is to tell us how to go to heaven, not how the heavens go." Now to the second fallacy, that religion and faith played either no role or a negative and adversarial role in the scientific revolution. Again, could not be further from the truth. In fact, religion, theology, and the churches, particularly the Catholic Church, supported and encouraged the study of the natural world in multiple ways. In the first place, one of the primary motivations for the study of the sciences at that time was religious and devotional. Those who studied the natural world saw their research as the study of God, but at one remove. That is, by studying the created works of God, they believed they were revealing God's thoughts. They were revealing sequentially more and more lines in the blueprint by which God created the universe. And this follows the well-known concept of the two books enunciated by the patristic authors, which holds that God reveals himself in multiple ways, by inspiring the sacred writers to pen the books of the Bible, and by the act of creating the world, that is, the book of nature. And the scientists of the scientific revolution sought to read that book of nature, to learn not only about nature itself, but to learn about what it says about nature's creator. The universe was to them, in a sense, a first incarnation, for everything simply by existing reveals God. Galileo himself taps into this idea when he writes about, quote, "that great book which is ever before our eyes, I mean the universe." So we must remember, I think one of the most important things to recall is that the thinkers of the scientific revolution had a much broader vision, a much more inclusive vision than do modern scientists. They were agglomerative, if I can put it that way, that their ideas were supposed to build together to a world system that explained everything and excluded nothing, rather than the way that modern science works, which divides things down into greater and greater specificity. The thinkers of the scientific revolution looked out on a deeply interrelated cosmos that had meaningful relationships everywhere among human beings, the created world, and God. Now, Galileo's contemporary, the astronomer Johannes Kepler, who enunciated the three fundamental laws of planetary motion, once lamented to his teacher that, quote, "I wanted to be a theologian, and I was sad for a very long time about that. But," he concluded, quote, "now I see how God is praised just as well by my work in astronomy." So see, once again, here he wanted to be a theologian. He didn't make it into theology school, had to end up being an astronomer, but yet he sees his astronomical work as fulfilling, in a sense, the very same function. Robert Boyle stated that he thought it was particularly appropriate to do chemical experiments on Sundays because it was, in fact, a kind of worship. Now, note that this viewpoint stretched across all the main Christian denominations of the day. I have just cited a Catholic, a Lutheran, and an Anglican. Others thought that scientific findings might be useful in a very practical sense for theology. The Minim priest Marin Mersenne studied what is called the mechanical philosophy, a worldview that holds that the universe functions like a great machine. It's materialistic in that sense, but it's a great machine with regular and predictable activity. So you should be able to predict and explain whatever happens once you understand how the mechanism's put together. Why? Because he hoped that learning about nature's regular laws would help solve the problem of discerning whether a remarkable event was natural or miraculous. To return a moment to Kepler, he used his mathematics and geometrical expertise to argue that Luther's doctrine of consubstantiation of the Eucharist could not possibly be true, and thus either the Catholic doctrine of transubstantiation or the Calvinist symbolic view had to be correct. He was actually excommunicated from the Lutheran Church for his effort in that regard. The churches, particularly the Catholic Church as an institution, fostered scientific study. Most obviously, it was the church that established and funded the universities which had grown out of cathedral schools. We have one example with Copernicus, who, when he comes up with the idea of heliocentrism, goes to Rome, gives a lecture before the Pope and the cardinals in 1515. They're so thrilled by this, they want him to publish straight away. Copernicus, very diffident about his ideas, demurs, but over the next almost 30 years, he has cardinals writing to him constantly saying, "Please, will you publish this? We will pay for the scribe, we will pay for the publication, we'll pay for the book, just please publish this is so important." The support given to those in holy orders, particularly among the Dominicans, the Franciscans, the Jesuits, the Benedictines, and the other orders, as well as by countless abbés, not only in terms of housing and sustenance, but in terms of freeing them from time-consuming and distracting familial responsibilities, let them spend more time on intellectual studies. And it's actually noteworthy to examine how many of the crafters of the scientific revolution, even those not in holy orders, remained bachelors. Likewise, the orders built the first global networks of correspondence and exchange. New scientific information and materials and reports flowed back to Rome through far-flung Jesuit missionaries in Asia, Africa, and the Americas, a sort of pre-modern internet, if you will, that both those orders that have a strong centralized structure, the Jesuits, the Dominicans, the Franciscans, could have this worldwide network that would send information back to Europe, where it was organized, codified, often published. So how can it be, given all this evidence to the contrary, that the ideas of inherent conflict between science and religion continue to be common narratives today? Well, strikingly, the origin of what many historians now call the myth that wouldn't die lies in the 19th century, and it actually centers on exactly two people. One, John William Draper, a physiologist and the first president of the American Chemical Society, and Andrew Dixon White, a New York State senator and first president of Cornell University. So now I'm going to slip a little bit forward in time by about 200 years, which for a medievalist is not that much, to talk about the origins of this conflict thesis, and then we'll get back to see its roots of the scientific revolution. So starting in the 1870s, both men wrote books chronicling what they described as an eternal conflict between science and Christianity. White was the more prolific. He published numerous articles in Popular Science Monthly, culminating in a massive 2-volume compilation published in 1896. Draper was the more popular. His book, published in a series of science popularizations, far outsold every other title in the series. Notice that both of these men were popularizers, so they reached a very, very large audience. Yet these writings are nothing more than a jumble of historical errors, misrepresentations, and outright fabrications. Their evidence is cherry-picked and often twisted to fit their authors' designs. But wait, you say, really? Come on, how many people have ever read Draper and White in this audience? That's what I thought. That's always the answer I get. So how is it affecting you? Okay, well, let me ask you another question. How many of you were taught or heard at one time or other that before the time of Columbus, people thought the world was flat? Okay, so you do know Draper and White. Virtually all of our fundamental errors about the history of science come out of these two authors. If you've ever heard, for example, that the Catholic Church forbade human dissection, how many of you got that one? All right. Once again, it's Draper and White. Total lie. By the end of the 13th century, to get a medical degree, you had to be present at a human dissection in a university that was founded and paid for by the Catholic Church. So, okay. The errors and outlooks, I think my little questionnaire for you there tells you that the errors of these books have become naturalized as facts in popular culture. Oh, I didn't get to say the one thing that I have to say. I am obliged to do this. I'll lose my license as a historian of science. The rotundity of the earth was fully well established by the 5th century BC, and nobody ever forgot it. Period. If you don't remember anything else, remember that. Okay. So the dubious facts upon which these books rest are easy to point out and refute, and many historians, including myself, have done that for the past 40 or 50 years. So I'm not going to do it again. Instead, I want to talk about their origins, because I think it's useful to understand those origins and conditions that made their ideas become so common. Well, interestingly, the origin of their beliefs, both cases, lie in very personal circumstances, not in the historical record. White's fulminations about science and religion resulted from his actions in founding Cornell University. As a New York state senator, he redirected federal funds from the 1862 Land Grant Act away from existing colleges in the state in order to found a new one. When he left the Senate to become that institution's first president, and his allied Senator Ezra Cornell obtained exclusive control over the funds and had the college named after him, well, guess what? The colleges that lost out in their share of the federal funds made accusations of impropriety, and not entirely unreasonably, I think. Since almost all of their colleges were denominational, which is the norm for American colleges at that time, White, rather than meeting the accusations directly, instead turned the affair into a matter of science versus religion, which of course it was not. White's grievances were renewed with repeated clashes with Henry Sage, chairman of Cornell's Board of Trustees, regarding the religious character of the institution. So White's writings are not dispassionate history, but rather over-the-top and misdirected responses to personal criticism and grievances. As one contemporaneous reviewer wrote, his final book is, and I quote, "an indiscriminate and uncritical agglomeration brought together for the support of a thoroughly one-sided and fatally misleading proposition, a piece of special pleading like this was not worth writing. Wow, if I got a review like that, I think I'd just stop. Well, Draper is actually more interesting because his thought can be characterized as an obsession, an absolute obsession with law. Through the 1840s, 50s, and 60s, he moved sequentially from the inanimate world through that of plants, animals, human beings, and human civilization, arguing that their life and development are governed entirely by impersonal and inescapable law, which he called the universal law of development. For him, he believed that for human beings, changes in climate bring about physiological changes, which in turn bring about intellectual changes, and thus societal changes. Just to give you an idea, he was one of the very first people ever to write a history of the American Civil War, published just months after the war ended. And his argument was that the reason that the Civil War happened, hold on to your seats now, is because the different climates in North and South transformed the people who lived there into essentially two different kinds of people, which of course inevitably came into contact. And the way to prevent another civil war was to build more north-south railroads so that people could move between the North and the South more easily and average out the climate. I am not making this up. His conflict between religion and science both continues this trend, but also departs from it in its melodramatic, in fact, hysterical tone. I find when I try and teach it to my students, I'm at an impasse trying to find a section out of it that won't send them into giggles to a 21st century mind. Its fulminations are not turned towards religion in general, but specifically against Catholicism. And the work is actually nothing more than one extended anti-Catholic rant. He considers Protestantism the twin sister of science, such that any persecution of science by Protestants comes solely from, quote, an incomplete emancipation from Catholicism. He calls Islam the Southern Reformation, carried out by a people ever benevolent to science and progress, while Catholicism is the brutal enemy of science, progress, and human civilization. Quote, Roman Christianity and science are recognized by their respective adherents, note that, are recognized by their respective adherents as being absolutely incompatible. They cannot exist together. Mankind must make its choice. It cannot have both. Well, there you have it. So Draper's rabidity aligns with contemporaneous American anti-Catholicism and panic over Catholic immigration. Heaven knows we don't know any panics over immigration in our enlightened age. Much of the success and continued popularity of the book depended upon its anti-Catholicism. But Draper's family history also played a role. His father was a Methodist minister who was a convert to Methodism, and his conversion resulted in his ostracism by the rest of the Draper family, which was, drum roll please, Catholic. Draper's sister Elizabeth, who came to America with him from England, converted to Catholicism while in America, and Draper threw her out of the house. Finally, conciliar and papal declarations helped drive Draper over the edge. In 1864, Pius IX issued a syllabus of errors that included such things as absolute rationalism and the denial of God's action in the world, two things that were deeply embedded in Draper's metaphysics. The First Vatican Council in 1870 spoke out against materialism, reasserted the role of faith, defended Christian education, and emphasized the role religion should play in the governing and guiding of society. And Draper saw these statements as challenges to his fully deterministic universal law of development. Well, once again, reviewers panned his book, quote, a more hasty, pretentious, incorrect work claiming the title of history has seldom fallen into our hands, wrote Scribner's Monthly, finding the book, quote, swarming with misstatements either positively erroneous or put into such a form as to be misleading. Yet this did nothing to dampen its popularity. It went through many, many printings. It was translated into multiple languages, particularly among those who shared the author's racism and anti-Catholicism. Its publisher, in fact, always eager about income, no doubt, asserted that the only criticism of the book came from, quote, the outside sects, Jews, Unitarians, and Catholics, whom the Orthodox repudiate as beyond the pale of Christianity and knowing nothing of true religion. So what is astonishing is how, despite the failings of both books, they set the tone for ideas about science and religion down to our own day. Again, even if you've never read them, their ideas have become embedded in sort of common knowledge of our day. But of course, they had help in becoming so popular. I've already mentioned contemporaneous social and political factors. In addition, there was the combination of progressivism and positivism of the French philosopher Auguste Comte, who enunciated 3 stages of development in science, in societies, which is one progenitor of Draper's universal law. These 3 stages were the religious or theological, the philosophical, and finally the scientific or positive. So when you hear, as one does, the claim that religion is primitive and science is advanced, you're really hearing an echo of Comte, even if the speaker has never heard of that French philosopher. Well, but religion itself, and now comes the part where we have to take a hard look at things. Religion itself, that is a particular subset of theology, I would say bad theology, must also bear part of the blame. And now we return to the scientific revolution and our third fallacy, that of the zero-sum game, that religion has to recede as science advances. More or less since the time of the scientific revolution, it does often look like science has been successively replacing religion as an explanation of our world. But this need not be the case, nor was it always the case. What I am referring to is what will be familiar to many of you, the so-called God of the gaps problem. Namely, the consequence when direct divine action is used to fill in gaps in our explanation of natural events or phenomena. The problem is that in most cases, the resort to God's action is a consequence of our limited knowledge. And therefore, as scientific understanding increases, the gaps become filled with natural explanation, and God, hence religion, is successively squeezed out of the picture. Let me jump back to the scientific revolution for one moment. At a famous meeting between Cardinal Roberto Bellarmino and Galileo, Galileo argued that he was able to reinterpret Scripture because of a scientific discovery he had made. Bellarmino said, maybe Galileo, but you haven't really proved it. So what would happen if we reinterpret the Bible or bring in religion as a corollary to every new scientific hypothesis? He says, come back to me, prove it, and then the correct authorities, not you, Galileo, but the theologians will reinterpret Scripture. But I need a proof. And the problem is, of course, science is always provisional. We are always learning more. Well, the origin of the God of the gaps argument lies itself in the scientific revolution. A classic example comes from Isaac Newton. He observed that the orbital velocities of the planets Jupiter and Saturn were changing. One planet was speeding up, the other planet was slowing down. Now, if such a change continued, our entire solar system would become unstable. But since the system has stayed stable, Newton suggested that God must intervene from time to set the system right again. Now, not only does this argument make God seem an incompetent workman who couldn't figure out how to design a good system, but moreover, 70 years later, Simon Laplace discovered how the system does in fact correct itself, what astronomers now know as the secular variation of the 2 major planets. God suddenly had one fewer thing to do. The same issue bedevils the argument from design, another development of the late 17th century, namely that complex structures like the eye or the hand had to have a direct designer, i.e. God, and thus prove his existence. But these many, many arguments from design, built up from the 17th to the 19th century and still encountered today in the 21st, were undermined by the discovery of evolution and natural selection. God, once again, found himself with less to do. Religion had picked the wrong horse, and so a natural extrapolation would be that religion always gets it wrong and God is unnecessary. Of course, this also ignores the fact that many of the gaps from which God was squeezed out were closed by religious believers. The monk Gregor Mendel for genetics, the priest Georges Lemaitre for Big Bang cosmology, to name just a few. The point is that God of the Gaps arguments were a bad move from the beginning, one of the negative developments of the scientific revolution. And it was, in fact, in large measure, a move by English Protestants, Dutch Protestants as well, to combat what they believed was a rising tide of atheism in their own day. In fact, the atheism panic of the late 17th and early 18th century seems to have been like looking for communists behind every bush. No historian has ever been able to point to, there's an atheist of the 17th century, except maybe Thomas Hobbes, but that's even questionable. So it was a sort of paranoid fear that drove them to this. Now, don't get me wrong. You see the title of our conference here. Wonder at the natural world can certainly intensify devotion in a believer. There's no question about that. And urge such a believer onwards towards discovering more about the world. Very important feature. That's a kind of natural theology that actually works. The problem is when it becomes a theological argument, because it's a very weak one, as the God of the Gaps problem shows. But you see, it didn't need to be so. The insertion of divine activity as explanations for details of the natural move was, as I say, a bad move from the start. And much, not all, of what is perceived today as a conflict between science and religion stems from errors in the assignment of causation. Errors generally linked to a bad theology and a bad exegesis. So just think about it. I'm up here running on as the ivory tower academic saying that really there isn't this conflict between science and religion, but we see it every day in the newspapers. Think about the exact contours of those conflicts. What are they really about? They're really about errors of causation, errors of biblical exegesis, errors in understanding how the omnipotent, eternal, transcendent God interacts with creation. So just think about that. Think, for example, let me give you an example, of the fundamentalists' insistence on a special creation, that is, each species has to be created independently, instead of evolution, or a young Earth created in a short period rather than an ancient Earth and universe. And it will surprise people to know that one of my colleagues in the history of science has recently published a book showing that the idea of a young Earth is actually a development of the 16th and 17th centuries, that there are plenty of examples of ancient and medieval thinkers who thought about an extremely ancient Earth. So this is to say that not everything that happened in the scientific revolution was in fact scientific, shall we say, progress or development. And of course, a kind of naive, literal, biblical literalism plays a big role, and its origins also date from the scientific revolution. Our medieval theologians would not have made either mistake. They saw calling in direct divine action to explain natural phenomena as an intellectual cop-out. And in doing so, these theologians defined a type of methodological naturalism that eventually would become central to modern science. What do we mean by methodological naturalism? You can only use natural causation to explain natural phenomena. That's not to say that there might not be a supernatural cause of things, but it's not part of the game if you're going to be doing science. It's not an allowed move on that chessboard. They also knew how to interpret the Bible, following the guidelines of St. Augustine. But both of these techniques were eroded and discarded to one degree or another, particularly in Northern Europe, toward the end of the scientific revolution. Thus, I think it's right to say that while science and Christianity were not in conflict during the scientific revolution, and that scientific thinkers of the period were themselves religious believers, and that the church supported science, it is also the case that some of the developments that would later unnecessarily bring science and Christianity into conflict also draw their origins from the same period. And these twin problems, that is, the erosion of methodological naturalism and of informed biblical exegesis, became far worse with the rise of fundamentalism in the early 20th century. But that's a different story, and one I don't have time to discuss today, perhaps mercifully. So in conclusion, I hope I've given you some information and insights to think about and succeeded in clarifying the content and impact of the scientific revolution and in relating its innovations, positive and negative, to subsequent developments down to our own day. And now I see I'm finished, right on time. Thank you for your attention.